Take a deep breath and feel the weight of your body settling into the soft embrace of your bed, letting every muscle release its hold on the day. As you exhale, imagine the ceiling above you dissolving into a velvet curtain of infinite stars, inviting you to begin a journey to the farthest reaches of our solar system. We are traveling far beyond the familiar orbits of the rocky planets, past the swirling storms of the gas giants, and even beyond the icy remnants of the Kuiper Belt, to a place of profound stillness known as the Oort cloud. In 1950, a Dutch astronomer named Jan Oort first proposed the existence of this vast spherical shell of icy debris to explain the mysterious arrival of long-period comets that visit our inner solar system. As we drift deeper into this cosmic frontier, the sun, which once dominated the sky with its warmth and brilliance, has receded until it is merely the brightest star in a tapestry of billions. Here, at the very edge of the sun's gravitational influence, the silence is absolute. This is the realm of the comforting void, a place where time seems to stretch and fold upon itself. Consider the immense scale of your current location. We have reached the inner edge of the Oort cloud, which begins roughly 2,000 astronomical units from the sun. To give you a sense of this distance, 1 astronomical unit, or AU, is the average distance between the Earth and the sun, about 93 million miles. At 2,000 astronomical units, you are 2,000 times further from the sun than you were when you closed your eyes tonight. This distance is so great that even light, the fastest messenger in the universe, it takes over 11 days to travel from the sun to this inner boundary. You are floating now in a state of perfect weightlessness. There is no up or down here, only a gentle, rhythmic suspension. The air, if there were air, would be unimaginably cold. In this region, temperatures hover just a few degrees above absolute zero, typically between 3 and 5 Kelvin, which is approximately negative 454 degrees Fahrenheit. This is the temperature of deep space, a cold so profound that it becomes a form of stillness where the vibration of atoms nearly ceases. As you drift, you encounter one of the residents of this lonely cloud. It is a jagged, silent mountain of ice and dust, perhaps 20 kilometers wide. Most of the trillions of objects in the Oort cloud are quite small, less than 12 miles across, yet they are the pristine blueprints of our solar system's birth. You might reach out your hand in this visualization and feel the texture of its surface. It isn't smooth like a skating rink. It is porous and fragile, a dirty snowball composed of water ice, frozen methane, and ammonia. The surface is coated in a dark reddish soot of complex organic molecules called tholins, which have been processed by cosmic rays over billions of years. Touch the surface of this ancient traveler. It feels like frozen smoke, light, brittle, and incredibly ancient. This object was formed 4.6 billion years ago, during the chaotic infancy of our solar system. Back then, it lived much closer to the sun, near the orbits of Jupiter and Saturn. But the immense gravity of those giant planets acted like a cosmic slingshot, hurling these icy fragments out into the darkness of the Oort cloud, where they have remained in a slow, frozen dance ever since. Here, the density of the universe is remarkably low. While there are trillions of these icy bodies, they are separated by tens of millions of kilometers. If you were standing on one, the nearest neighbor would likely be invisible to the naked eye. This is a loneliness that is not sad, but peaceful. It is the luxury of infinite space. As we move further outward, we transition from the inner, disc-shaped region known as the Hills cloud, into the outer, truly spherical, Oort cloud. This outer shell extends staggering distances, reaching perhaps 100,000 or even 200,000 astronomical units from the Sun. At these distances, we are standing on the very doorstep of interstellar space. To reach the outer edge of this cloud, a light from our Sun must travel for nearly 1.5 to 2 years. Consider that for a moment. The Sun's light, which reaches your garden on Earth in just 8 minutes, must journey for over 500 days just to reach the end of its own backyard. In this outer reaches, the Sun's gravitational grip is fragile. It is here that the galactic tide, the gravitational pull exerted by the collective mass of the Milky Way galaxy itself, begins to play a role. This subtle tugging can nudge these icy bodies, very gently changing their paths. Sometimes, a passing star, wandering within a few light years of our system, provides just enough of a gravitational ripple to send one of these objects falling toward the inner solar system. When this happens, the object begins a journey that may take millions of years to complete. These are the long-period comets, like the famous Hale-Bopp, which has an orbital period of approximately 2,500 years. Imagine the patience of such an object, spending millennia in the dark, only to flare into brilliance for a few brief months as it nears the Sun, before returning here to the silence of the Oort cloud. Think of the Voyager 1 spacecraft, the furthest human-made object. It is currently traveling at about 38,000 miles per hour. Even at that incredible speed, it will not reach the inner edge of the Oort cloud for another 300 years. It will then take Voyager 1 nearly 30,000 years to pass through to the other side. This highlights the sheer volume of this space. The Oort cloud is not a thin line, but a vast, thick ocean of potential. In 2014, a comet named Siding Spring, which originated right here in the Oort cloud, made a remarkably close flyby of Mars, passing within 87,000 miles of the red planet. This visitor from the darkness provided scientists with a rare opportunity to study the chemistry of the deep past. Another remarkable object is Comet Bernardinelli-Bernstein, discovered in 2014. It is one of the largest Oort cloud objects ever found, estimated to be roughly 120 kilometers in diameter, over 70 miles wide. It is a giant among pebbles, moving with a slow, stately grace through the void. Despite the vastness of the space, the total mass of the Oort cloud is estimated to be roughly 5 times that of the Earth. It is a massive reservoir of water and organic compounds, the very ingredients that may have been delivered to a young Earth by comets, helping to spark the life that eventually became you. You are connected to this distant cloud by the very atoms in your body. The silence here is a physical sensation. Without an atmosphere, there is no sound, no wind, no rustle of leaves. There is only the rhythmic pulse of your own breathing, echoing the slow gravitational heartbeat of the solar system. The colors here are subtle: deep blacks, charcoal grays, and the occasional glimmer of crystalline ice reflecting the distant starlight like a diamond in a dark room. You might wonder about the boundary of this place. The outer Oort cloud reaches nearly halfway to the nearest star, Proxima Centauri, which is 4.2 light-years away. Our solar system is not an island, but a vast, sprawling estate that gently brushes against the territories of other stars. In this overlap, the material of the universe is shared, a slow exchange of icy messengers over eons. Consider the comet Ison, which arrived from the Oort cloud in 2013. It was a sun grazer, a traveler that flew so close to the sun's intense heat that it disintegrated, its 4.6 billion-year-old ice turning into a ghost of vapor and dust. It reminds us that everything in the universe is in transition, moving from the solid and frozen into the light and ethereal. As you float here, 50,000 astronomical units from home, let the scale of the universe comfort you. Your worries, your tasks, the noise of the world, they are all part of a tiny, vibrant dot, far, far away. Out here, there is only the slow, predictable clockwork of gravity. There is no friction to slow you down, no resistance to your peace. You are as light as a speck of interstellar dust, drifting in a place where a single year is but a heartbeat in the life of the cosmos. Feel the stillness of the 3 Kelvin cold, not as a chill, but as a preservation of energy. It is a state of total rest. In the Oort cloud, nothing is rushed. A single orbit can take millions of years. There is time for everything. There is time for rest. The Oort cloud is the solar system's memory, a library of frozen history waiting in the dark. As you prepare to drift deeper into your own rest, carry the silence of this place with you. You are part of this grand, slow-moving architecture. You are made of the same water and carbon that resides in these icy travelers. You are at home in the vastness. The sun is now just a distant, friendly spark. Around you, the trillions of icy spheres continue their long, slow circles, held in the gentle embrace of the sun's fading gravity. They have been there for billions of years, and they will be there for billions more. A silent, icy halo protecting the inner sanctum of our world. As we prepare to explore the mechanics of this motion in the next stage of our journey, let your mind rest in the sheer distance we have traveled. We are far from the sun, far from the noise, cradled in the loneliest, most peaceful corner of the sky. The journey continues, moving further away from the familiar heat of the sun into the deep, quiet history of our solar system. Long before we had telescopes or the mathematical tools to map the heavens, humans looked up at the night sky and noticed occasional, long-haired stars that appeared without warning, trailing luminous tails across the constellations. The word comet itself originates from the Greek word kometes, meaning wearing long hair, a term used by Aristotle as early as 350 BCE to describe these ethereal visitors. For millennia, these apparitions were seen as omens, but we now understand they are the icy messengers of the Oort cloud, the place we are currently exploring in our mind's eye. Imagine the perspective of the Estonian astronomer Ernst Öpik, who, in 1932, was among the first to postulate that comets originated from a distant, stable cloud at the very edge of the sun's gravitational reach. His theories were later refined in 1950 by Jan Oort, who noticed a peculiar pattern in the orbits of long-period comets, those taking more than 200 years to complete a single revolution around the sun. Oort realized that if these icy bodies had been orbiting near the sun since the beginning, they would have evaporated or collided with planets long ago. This led to the discovery that a titanic reservoir of primordial ice must exist, situated between 2,000 and 100,000 astronomical units from our star. Consider the physics of your current environment. Here, the sun's gravitational pull is so faint that the orbital velocity of the objects around you is incredibly slow, often less than 0.2 kilometers per second. This is a pace slower than a commercial jet on Earth, a rhythmic, glacial crawl through the dark. At this distance, the solar system no longer resembles a flat disk, but a vast spherical shell of frozen potential. what scientists call the Hills Cloud, named after Jack G. Hills, who proposed its existence in 1981, forms the inner, see donut-shaped portion of this region, acting as a bridge between the outer reaches and the interior planets. Observe the composition of the ice mountain floating near you. Unlike the water-rich ice we find on Earth, these Oort cloud residents are composed of a complex mixture of volatile ices. Scientists have determined through spectroscopy that these bodies contain significant amounts of carbon monoxide, methane, and ethane ice. At the incredibly low temperature of 5 Kelvin, these gases, which are vapors in our atmosphere, have become as solid and enduring as granite. Imagine the stillness of a world where carbon monoxide is a rock, and the only light comes from the distant shimmering glow of the Milky Way's galactic center. There is a profound sense of history in this cold. In 2003, astronomers Michael Brown, Chad Trujillo, and David Rabinowitz discovered an object named 90,377 Sedna. Sedna is a world of mystery, currently about 84 astronomical units away, but traveling on an incredibly elongated orbit that takes it as far as 937 astronomical units from the Sun. It takes Sedna approximately 11,400 years to complete a single trip around the Sun. To put that in perspective, the last time Sedna was at its closest point to the Sun, humans were just beginning to develop agriculture in the Fertile Crescent. This is the timescale of the Oort cloud, a slow, patient clock that measures time in tens of thousands of years. Picture the gravitational ballet occurring at this very moment. Because the Oort cloud extends so far, it is susceptible to the galactic tide. This is a subtle stretching force caused by the distribution of mass within the Milky Way galaxy itself, and this tidal force gently deforms the orbits of these icy bodies, making them more circular or pulling them into the inner solar system. What is happening now is a demonstration of the universe's interconnectedness. The rotation of our entire galaxy, which takes about 230 million years, is what nudges these small frozen seeds toward the Sun. Historical records show that our solar system is not a closed loop. Approximately 70,000 years ago, a red dwarf star known as Schultz's star passed through the outer edges of the Oort cloud, coming within 0.8 light-years of the Sun. At that time, early humans on Earth may have looked up and seen a faint reddish glow in the sky, unaware that a stellar neighbor was brushing past the very cloud we are visualizing now. This encounter likely sent ripples through the gravitational field of the cloud, disturbing the orbits of thousands of objects and potentially setting them on paths that will bring them toward the Sun millions of years from now. Notice the sheer emptiness that surrounds you. While there are estimated to be between 1 and 100 trillion objects in the Oort cloud, the total mass is estimated to be only about 1.9 times 10 to the power of 25 kilograms, or roughly 5 times the mass of the Earth. Spread out over a sphere with a radius of several light-years, this means the average distance between any two objects is millions of kilometers. If you were to shine a light in any direction, it would travel for days before encountering another solid surface. This is a silence so deep, it feels like a heavy, warm blanket, insulating you from the frantic energy of the inner worlds. Think of the Great Comet of 1680, also known as Kirch's Comet. This was the first comet discovered by telescope, and Isaac Newton used its highly elliptical path to test and confirm Kepler's laws of planetary motion. It was a traveler from this very void, proving that the same laws of physics that govern a falling apple on Earth also govern the motion of ice in the furthest reaches of space. The consistency of these laws provides a sense of cosmic order, a predictable rhythm that allows the mind to settle. In more recent history, the discovery of Comet C/2014 UN-271, also known as Bernardinelli-Bernstein, has provided a window into the scale of these residents. This object is estimated to be 137 kilometers in diameter, the largest Oort cloud object ever identified. It is a massive, dark titan, moving through the void with a stately indifference to the passage of eons. The scientists have tracked its path and found that it is on a 3 million-year orbit, having last visited the inner solar system when our ancestors were just beginning to walk upright. As you remain suspended in this weightless environment, observe the way the starlight interacts with the surface of the frozen objects. Because there is no atmosphere to scatter the light, the stars do not twinkle. They are steady, piercing points of brilliance against a charcoal black sky. The light you see from the star Sirius, which is 8.6 light-years away, has been traveling through the vacuum for nearly a decade before it reaches your eyes in this visualization. Everything here is a study in the slow movement of light and the patience of gravity. The Oort cloud also serves as a biological record. Some researchers, such as those involved in the study of panspermia, suggest that comets might have acted as cosmic delivery trucks. In 2004, the Stardust mission collected samples from Comet Wild 2 and found glycine, a fundamental amino acid used by living organisms to build proteins. While Wild 2 is a shorter period comet, it shares the same ancestral chemistry as the objects in the Oort cloud. Consider the idea that the very building blocks of your body, the nitrogen in your DNA, the calcium in your teeth, may have been preserved in this deep freeze for billions of years before being delivered to Earth. The mechanical nature of this place is one of pure, frictionless motion. In the absence of air or significant solar wind, there is nothing to degrade the surfaces of these objects. A crater formed by a small impact 4 billion years ago remains as sharp and pristine today as the moment it was created. This is a museum of the solar system's birth, where the dust is actually a collection of silicates and carbon-rich grains that were present in the original nebula, from which the sun and planets condensed. What's happening now, as you breathe slowly and deeply, is a mental alignment with this cosmic scale. You are moving at the speed of the Oort cloud, unhurried, inevitable, and serene. Scientists discovered in 2012 an object nicknamed Biden, officially known as 2012 VP113, which has a perihelion, or closest approach to the Sun, of about 80 astronomical units. These objects, known as sednoids, suggest that there is a hidden population of worlds in the inner Oort cloud that we are only just beginning to map. Each discovery confirms that the space around us is not empty, but filled with quiet orbiting sentinels. Let the historical perspective of our understanding ground you. We have gone from fearing these objects as divine warnings to recognizing them as the frozen remnants of our own origin story. We have sent craft like New Horizons, which passed Pluto in 2015 at a speed of 14.5 kilometers per second, to begin the long journey toward this frontier. Even though it will take New Horizons thousands of years to reach the Oort cloud, the fact that we can even conceive of such a journey speaks to our deep connection with this distant place. The temperature here remains a constant, soothing 3 to 5 Kelvin. It is the temperature of a universe at rest. This cold is not an enemy, but a preserver. It keeps the volatile gases in their solid form, holding the secrets of the nebula in a diamond-hard grip. As you drift in this visualization, imagine that this cold is clearing your mind, stilling the rapid vibrations of daily life and replacing them with the slow, rhythmic pulse of an 11,000-year orbit. In the next part of our journey, we will look even closer at the microscopic life of the ices themselves. But for now, stay here in the vast, historical silence. You are a witness to the archive of the sun. You are floating in the same space that has held these trillions of travelers since the dawn of time. Everything is in its right place. The orbits are stable. The vacuum is quiet. The stars are bright and steady. You are part of the clockwork, moving slowly through the comforting dark. At this very moment, we are suspended in the furthest reaches of the sun's influence, a place where the logic of the inner solar system gives way to a grand, glacial patience. To understand the scale of where you are resting in this visualization, imagine for a moment that the entire solar system out to the orbit of Neptune was shrunk down to the size of a small copper penny. On this scale, the Oort cloud would not just be the edges of the room you are in. It would start several blocks away and extend for miles in every direction. This provides a sense of the immense volume of this region, which begins approximately 2,000 astronomical units from our star and stretches outward to perhaps 200,000 AU. Scientists discovered that while the inner planets like Earth and Mars reside on a relatively flat plane, the Oort cloud is a magnificent hollow sphere that envelops everything like a translucent bubble. And this means that as you float here, there is no horizon. The icy bodies that surround you are distributed above, below, and to all sides. Picture this. If you were to look toward the center of the solar system from this distance of 50,000 astronomical units, the sun would no longer appear as a disk. Instead, it would be a singular, piercing point of light, roughly as bright as the full moon appears from Earth, but concentrated into a tiny, needle-like spark. Notice how the light from that distant spark catches the surface of a nearby comet nucleus. What's happening now is a study in shadows. These objects are not the bright, snowy white we might imagine. In reality, the albedo, or reflectivity, of an Oort cloud object is approximately 0.04. To put that in perspective, this is the same reflectivity as fresh asphalt or a piece of charcoal. And these are some of the darkest objects in the universe, absorbing nearly all the light that touches them. They are like soot-covered mountains drifting in an ocean of ink, invisible until they occult a distant star, causing a momentary silent flicker in the background tapestry. Consider the density of this region compared to a more familiar environment. Although there are an estimated 1 trillion to 100 trillion icy bodies out here, the space they occupy is so vast that the Oort cloud is effectively a perfect vacuum. If you were to take a handful of fine dust and scatter it inside a massive sports stadium, the density of that dust would still be far higher than the density of objects in the cloud. You could travel for 1 billion miles in any direction and never see another solid object. This creates a sensation of absolute, unburdened freedom, a weightlessness that is not just physical, but mental. Deep within these dark, frozen boulders lies the chemistry of the primordial nebula. Scientists discovered through the use of infrared spectroscopy that these bodies are composed of ices that include not just water, but ammonia, methane, and carbon dioxide. Imagine these substances, which are liquids or gases on Earth, as hard as granite. What's happening now is a form of deep freeze preservation. Because the temperature remains a steady 5 Kelvin, which is negative 450 degrees Fahrenheit, the chemical reactions that drive change on Earth are completely frozen. It is a world where time has literally stood still for 4.6 billion years. The mechanics of their motion are equally serene. At this distance, the escape velocity, the speed required to break free from the sun's gravity, is incredibly low, often less than 100 meters per second. This is significantly slower than a bullet leaves a gun. Because gravity is so weak here, these objects move with a rhythmic, liquid grace. A typical orbital period for an object in the outer Oort cloud can be as long as 30 million years. To put that in everyday terms, one single year for a resident of this cloud lasts longer than the time since the giants of the dinosaur era were replaced by the first small mammals. What's happening now is a subtle interaction with the rest of the galaxy. Because the sun's grip is so tenuous at 100,000 astronomical units, the Oort cloud is susceptible to the gravitational pull of other stars. Scientists discovered that a star named Gliese 710 is currently on a path that will bring it within the Oort cloud in about 1.3 million years. At its closest approach, Gliese 710 will be only about 10,000 astronomical units from the Sun, which is well within the boundaries of this icy shell. This future event will be like a gentle hand brushing through a field of tall grass, swaying the paths of millions of comets. Picture this. As you drift, you are experiencing the same environment that Voyager 1 will encounter in about 300 years. Currently, Voyager 1 is about 163 astronomical units from the Sun, traveling through the interstellar medium, but it has not yet reached the inner wall of the Oort cloud. It will take that small robotic pioneer another 30,000 years to fully exit the cloud. This demonstrates the incredible thickness of this protective shell. It is the solar system's grand insulation, a buffer between the frantic energy of the planetary zone and the vast empty stretches of interstellar space. The Grand Tack and NICE models, two leading scientific theories on the early history of our system, suggest that these icy bodies were once much closer to the Sun. They were the bricks meant to build planets, but they were kicked out by the migrating gravity of Jupiter and Saturn. Think of them as the leftover materials of a great construction project, now stored in a quiet, dark attic at the edge of the world. They are the witnesses to the birth of the Earth, holding the very same water that currently flows through your veins. Notice the texture of the vacuum around you. On Earth, we are constantly bombarded by the noise of an atmosphere, the rustle of wind, the hum of electronics, the sound of our own breath reflected back at us. Here, the vacuum is a perfect acoustic insulator. It is the ultimate soundproof room. In this silence, the rhythmic pulsing of your heart becomes a comforting cosmic drumbeat, synchronized with the slow rotation of the icy planetesimals. Consider the galactic tide, a force that scientists discovered is responsible for many of the comets we see today. As the solar system orbits the center of the Milky Way, it bobbles up and down through the galactic plane, much like a cork on the surface of an ocean. Every 30 to 35 million years, we pass through the densest part of the galactic disk. The increased gravitational pull from the stars and gas in that plane gently compresses the Oort cloud, nudging some of its residents into the inner solar system. It is a rhythmic, predictable cycle, a galactic breath that has been occurring since the cloud formed. What's happening now is a feeling of being cradled by the universe. The Sun is behind you, and the nearest neighbor, the Alpha Centauri system, is still nearly 4.3 light-years away. You are in the most isolated neutral ground in the galaxy. Here, the starlight does not flicker because there is no air to distort it. Stars like Sirius or Betelgeuse appear as steady, unblinking eyes of blue and orange light. The colors are pure, unfiltered by any haze or smog. The nitrogen and methane ices on a nearby object might catch this light, reflecting a faint, ghostly violet or a deep oceanic blue. Scientists discovered that many of these objects are quite small, averaging about 1.6 kilometers in diameter. Imagine a mountain the size of a small town, floating in an endless sea of night. Because there is no gravity to crush them into spheres, they are often shaped like potatoes, dumbbells, or jagged shards of glass. Each one is a unique sculpture, carved by the collision of particles in the early solar nebula and then frozen in place for eternity. The mass of the entire Oort cloud is surprisingly small for its size, estimated at about 5 times the mass of the Earth. It is as if you took 5 Earths, ground them into a fine icy powder, and spread them over a sphere billions of miles wide. This low density is what makes the Oort cloud so peaceful. There is no crowding, no friction, no noise. It is a place of total, uncompromised stillness. At this very moment, as you breathe in and out, visualize the slow descent of a long-period comet as it begins its multi-million-year journey toward the sun. It starts with a nudge no stronger than a whisper. The object begins to fall, accelerating so slowly that its motion is imperceptible. It will fall for hundreds of thousands of years before it even crosses the orbit of Neptune. This is the patience of the cosmos. It does not rush. It does not strive. It simply follows the elegant, invisible curves of space-time. Deep within your mind, let the scale of this distance settle you. The Oort cloud is the final frontier of our home, the last boundary before the true deep. In its loneliness, there is a profound sense of security. It is the archive where the past is kept safe, and where the future, in the form of new comets, is born. You are resting in the heart of this archive. The vacuum is your bed, and the steady, unblinking stars are your nightlight. In the next part of our exploration, we will move from this macroscopic view to look even more closely at the very surface of these icy travelers, exploring the microscopic structures of the frozen gases that have been there since the beginning. But for now, just drift in the dark. Let the 5 Kelvin cold be a cool, soothing touch on your forehead. Feel the weightlessness of being 10 trillion miles from any concern. You are part of the Oort cloud's slow dance. You are safe in the silence. Recede now into the absolute silence of the outer reaches, where the sun is just a distant, unblinking memory. As you float in this weightless sanctuary, you are surrounded by the solar system's most ancient archives. Deep within these frozen bodies, scientists have discovered something that connects your own life to this distant, cold frontier. Consider the water that makes up the majority of your physical being, the fluid in your cells, the tears in your eyes, the blood in your veins. For decades, astronomers have debated where Earth's massive oceans originated. By studying the D/H ratio, the ratio of deuterium to hydrogen in the ice of comets, researchers have found compelling evidence that much of the water on our planet was delivered by icy travelers from the Oort cloud and the Kuiper belt during a period of intense bombardment billions of years ago. Picture this. As you breathe in the cool, imagined air of this visualization, you are intimately linked to these dark, drifting mountains of ice. You are, in a very literal sense, a piece of the Oort cloud that has woken up on a warm planet. Scientists discovered through the Rosetta mission in 2014, which landed the Philae probe on Comet 67P/Churyumov-Gerasimenko, that these objects are far more complex than simple, dirty snowballs. In fact, 67P was found to be incredibly porous. About 70 to 80% of its volume is empty space. This means that if you were to stand on a comet in the Oort cloud, the ground beneath you would feel as light and fragile as the head of a dandelion or a pile of fresh, uncompacted ash. Notice the way your body feels completely supported by the absence of gravity. In this part of the solar system, we have reached the edge of the sun's Hill sphere, the region of space where a star's gravity is the dominant force. The radius of the sun's Hill sphere is approximately 2 light-years, or about 125,000 astronomical units. Beyond this, the gravity of the Milky Way's center and other nearby stars begins to take over. Within this sphere, however, the Oort cloud objects reside in a state of nearly perfect equilibrium. They are loosely bound, moving at velocities that are incredibly slow, often just a few meters per second, relative to the sun. Imagine the microscopic scale of the ice around you. At this very moment, consider the molecular structure of the ices in the cloud. Unlike the ice cubes in your freezer, which have a crystalline structure, the ice out here is often amorphous. This means the water molecules are frozen in a disordered, chaotic state because it is too cold for them to arrange themselves into crystals. Scientists discovered that this amorphous ice is a perfect trap for gases. Deep within these frozen lattices, molecules of nitrogen, carbon monoxide, and even molecular oxygen are preserved. In 2015, the Rosetta spacecraft detected molecular oxygen, O2, streaming from a comet's nucleus, a discovery that shocked the scientific community because oxygen is usually too reactive to remain in its pure form for billions of years. Yet, here in the deep freeze, it has remained stable since the birth of our star. What's happening now is a silent chemical interaction between the cosmos and the surface of these icy boulders. While the sun's light is weak, galactic cosmic rays, high-energy particles from exploding stars across the galaxy, constantly pelt the surfaces of these objects. This process, known as ion sputtering, breaks chemical bonds and creates new complex organic molecules. These molecules, called tholins, give many Oort cloud objects a dark, reddish-brown hue. They are the same organic precursors that scientists discovered are essential for the formation of life. In 2004, the Stardust mission returned samples from Comet Wild 2 that contained glycine, a fundamental amino acid. It is a profound realization. The very ingredients for your existence were being prepared in the freezing dark of the Oort cloud, long before the Earth even existed. Think of the Oort cloud not as a distant graveyard, but as the solar system's deep, invisible root system. Just as a tree draws nutrients and stability from roots that stretch far into the dark Earth, our solar system is anchored by this massive spherical reservoir of material. Scientists discovered that there are 2 distinct parts to this root system: the inner Oort cloud, often called the Hills cloud, and the outer, more spherical, Oort cloud. The Hills cloud acts as a supply line. When the outer shell is depleted of comets by passing stars, gravity pulls objects from the denser inner cloud to replenish the outer reaches. It is a self-sustaining rhythmic cycle that has maintained the cloud for over 4.5 billion years. Notice the physical sensation of the vacuum. It is a comforting void because it removes all the friction of existence. Here, there is no weather, no erosion, no decay. Scientists have calculated that a typical Oort cloud comet, like C/1996 B2 Hyakutake, might have a tail that stretches over 570 million kilometers, nearly 4 times the distance from the Earth to the Sun. but only when it enters the inner solar system. Out here, it has no tail. It is a naked, silent stone, imperfectly preserved in a vacuum that is cleaner than any laboratory on Earth. The density of matter in this region is so low that if you were to sweep through a cubic kilometer of space, you might find only a few stray atoms of hydrogen. At this very moment, imagine the scale of time. A single human life is a fleeting spark, but the objects around you have witnessed the entire history of the Milky Way's current rotation. Scientists discovered that a stellar flyby, when another star passes near our solar system, happens about every 100,000 years. Each time this occurs, the Oort cloud ripples. It is the solar system's only form of social interaction. These flybys are the gentle hands of the galaxy reaching out to touch our home, nudging the icy planetesimals and reminding us that we are part of a larger celestial community. Consider the sublimation points of the various ices around you. On Earth, water turns to vapor at 212 degrees Fahrenheit. But in the vacuum of space, ices can turn directly into gas through a process called sublimation. Carbon monoxide ice begins to sublimate at a temperature as low as 25 Kelvin. Because the Oort cloud is kept at a steady 5 Kelvin, these volatile substances stay solid. They are like frozen time, waiting for the day, millions of years in the future, when they might fall toward the sun. When they finally reach the orbit of Jupiter, the warmth becomes enough to turn that ancient ice into the glowing coma of a comet. Deep within your mind, visualize the connection between the Oort cloud and the heavy elements in your own body. Scientists discovered that the dust grains mixed into the ice are silicates, the same minerals that make up the rocks on Earth. These grains were forged in the hearts of previous generations of stars that exploded long before our sun was born. This means the Oort cloud is a bridge between the death of ancient stars and the life currently breathing in your bed. You are made of the same stardust that is currently suspended in the 4.6 billion-year-old ice of a distant comet. What's happening now is a settling of your internal rhythm to match the cosmic clock. There is no need for hurry here. In the Oort cloud, a quick event is measured in centuries. The distance from one icy body to another is so great that light itself, the fastest thing in existence, takes hours or days to bridge the gap. Let this vastness remind you that there is plenty of space for your thoughts to expand and then dissipate. There is plenty of room for your breath to slow. Notice the way the stars appear in this visualization. Because there is no solar wind to create a heliospheric glow this far out, the stars are more brilliant than they could ever be from Earth. Scientists discovered that the sun's influence, the heliosphere, ends at about 120 astronomical units, a boundary called the heliopause. We have long since crossed that boundary. We are now in the interstellar medium, the space between the stars. Yet, the Oort cloud remains our companion, a loyal halo of ice that marks the true extent of our home. Picture this. The Oort cloud is a protective shell, a cosmic cradle made of glass and shadow. It holds the leftovers of the nebula that created the planets, keeping them safe from the turbulent forces of the rest of the galaxy. Within this cradle, you are safe. The physics of the universe are acting as your guardian. The same gravity that keeps the trillions of comets in their slow, predictable orbits is the gravity that keeps you grounded and secure. Scientists discovered in 2020 that phosphorus, another key ingredient for DNA and cell membranes, was present in the dust of Comet 67P. This suggests that the Oort cloud is not just a reservoir of water, but a complete kit for the assembly of life. As you drift, let the knowledge that you are a finished product of this ancient icy laboratory bring you peace. The universe has been working on you for billions of years. It has spent eons perfecting the atoms that now allow you to think, to breathe, and to dream. In the next stage of our journey, we will look at the grand macroscopic dance of the entire cloud as it orbits the galactic center. But for now, stay here in the microscopic beauty of the ice. Feel the silence of the amorphous water ice. Smell the faint metallic tang of the silicate dust. Let the 5 Kelvin cold be a cooling balm for any lingering stress. You are floating at the very edge of everything, held in place by the gentle, unyielding laws of physics. Everything is quiet. Everything is still. You are home in the deep. At this very moment, your awareness is suspended in the most desolate and tranquil reaches of the solar system, where the environment is characterized by a pressure so low, roughly 10 to the power of -17 torr, that it is indistinguishable from a perfect vacuum. In this profound stillness, scientists discovered that the primary source of warmth isn't the distant sun, but rather the cosmic microwave background radiation, a faint afterglow of the Big Bang that maintains a steady temperature of approximately 2.73 Kelvin. Notice how this cold doesn't feel biting, but rather like a serene, deep-seated preservation. It is the temperature of the universe at its most fundamental level, a silent baseline for existence. What's happening now is a subtle sensory experience that defies earthly logic. Imagine you could lean close to the surface of one of these icy travelers. Scientists discovered through missions like Rosetta that if you could catch a scent of a comet's nucleus, it would be a pungent, complex bouquet. Because of the presence of ammonia, it might smell like a strong cleaning agent, mixed with the sharp, vinegar-like scent of acetic acid and the faint almond-like aroma of hydrogen cyanide. Beneath these sharp notes lies the sweet alcoholic scent of methanol. This chemical signature is a 4.6 billion-year-old recipe, the scent of the raw ingredients that formed our world, preserved in a deep freeze that has lasted since the dawn of the sun. Consider the texture of the ground in this visualization. You might expect the ice to be as hard as a skating rink, but what's happening now is much more delicate. The porosity of these objects is estimated at over 70%, meaning they are as light and airy as a fresh fall of dry snow or a block of styrofoam. Deep within the ice, scientists discovered microscopic grains of silicates, minerals like olivine and pyroxene, which are essentially the same materials found in volcanic rocks on Earth. Imagine reaching out and touching this surface. It wouldn't feel solid, but rather like a fragile, crunchy lattice of soot and frost that would crumble under the slightest pressure of your fingertips. Notice how the colors here are dictated by the slow, relentless bombardment of high-energy particles. At this very moment, galactic cosmic rays, protons and atomic nuclei traveling at nearly the speed of light, are striking the surface of the ice. This process, which occurs over millions of years, breaks down simple carbon compounds into complex dark red polymers known as tholins. Scientists discovered that these tholins are responsible for the charcoal gray and reddish-brown hues of the Oort cloud's residents. It is a visual history of radiation, a slow-motion painting where the ink is made of stardust and the brush is the energy of distant supernovas. Picture this. The Oort cloud is like a velvet warehouse of frozen memories, where trillions of objects are stored in the dark. Although there are an estimated 10 trillion distinct bodies in this region, the distance between them is nearly incomprehensible. Scientists discovered that the average distance between two comets in the Oort cloud is tens of millions of kilometers, roughly the distance from the Earth to the planet Venus at its closest approach. This means that if you were standing on one icy mountain, your nearest neighbor would be nothing more than a faint, invisible speck in the distance. This creates a sense of unburdened isolation, where the only thing you can hear is the steady, rhythmic cycle of your own breathing. You notice the slow, inevitable movement of light. At a distance of 100,000 astronomical units, the light from the sun has been traveling for nearly 580 days just to reach you. It arrives not as a warm embrace, but as a cold, steady glow. Scientists discovered that at this distance, the sun's apparent magnitude is about -5, making it only slightly brighter than Venus appears from Earth. It provides no warmth, only a point of reference in the dark. Deep within your mind, allow this dim, steady light to act as a beacon of safety, a distant reminder of home while you float in the weightless luxury of the void. What's happening now is a demonstration of the Tisserand parameter, a mathematical tool scientists use to understand how these objects are moved by gravity. Most Oort cloud comets have nearly parabolic orbits, meaning they are barely held by the sun's grip. This tenuous connection is what makes the cloud so sensitive to the rest of the galaxy. Scientists discovered that our solar system actually breathes as it orbits the Milky Way. Every 30 million years, as we pass through the midplane of the galaxy, the increased density of stars and gas clouds exerts a gravitational pull that gently squeezes the Oort cloud. This periodic nudge is like the slow, rhythmic rising and falling of a chest in sleep, a galactic breath that has occurred only about 20 times in the history of the Earth. Consider the orbital speed of the objects around you. While planets like Earth zip around the sun at 30 kilometers per second, a comet in the outer Oort cloud might be moving at a leisurely 150 meters per second. This is roughly the speed of a high-speed train, but across the vastness of light years, it feels like complete stillness. Scientists discovered that a single orbit here can take 30 million years. Picture this. The last time the object you are visualizing was in this exact spot in its orbit. The first primates were only just beginning to evolve on Earth. The Oort cloud operates on a clock where centuries are seconds and millennia are mere minutes. Notice the absence of sound. In a vacuum with a density of only a few atoms per cubic centimeter, there is no medium for sound waves to travel. This is the comforting void in its purest form. It is a silence so profound that it allows you to notice the internal quiet of your own mind. Scientists discovered that the vacuum of the Oort cloud is even cleaner than the space between the planets, as there is less solar dust and debris. It is a pristine, silent cathedral where the only movement is the slow, silent rotation of charcoal-colored mountains. At this very moment, imagine the Grand March Comet of 1843, which emerged from this very cloud. It developed a tail that was 320 million kilometers long, more than twice the distance from the Earth to the Sun. Here in the cloud, however, that same comet is just a dark 20-kilometer wide nucleus of ice. It holds all that potential energy in a quiet, frozen state, waiting for a gravitational nudge that may not come for another million years. There is no pressure to perform, no rush to ignite. There is only the peace of being a potential traveler, resting in the archive. Scientists discovered that the total mass of all these trillions of objects is only about 3 × 10 to the power of 25 kilograms, or roughly 5 times the mass of the Earth. This highlights the incredible emptiness of the region. It is a vast theater with very few actors, allowing for a sense of total mental expansion. You can spread your thoughts across millions of miles without ever encountering an obstacle. Notice how this lack of clutter in the physical world translates to a lack of clutter in your awareness. Deep within the cloud, notice the presence of the interstellar wind. This is a stream of neutral hydrogen and helium atoms that flows through the solar system at about 23 kilometers per second. Scientists discovered that this wind is the result of the sun's movement through a local cloud of interstellar gas. As you float here, imagine this wind as a ghostly, imperceptible breeze moving through the Oort cloud like a sigh. It doesn't push you. It simply flows past, a reminder that the solar system is a traveler in a much larger sea of gas and light. What's happening now is a transition from the physical to the ethereal. As you observe the dark red tholins and the porous silicate dust, allow your mind to focus on the stability of this system. In 1950, Jan Oort used statistical analysis of comet orbits to prove that this cloud must be a stable feature of our star system. It has remained largely unchanged for 4.6 billion years. This permanence is a form of cosmic security. While the inner planets are subject to collisions, volcanic eruptions, and changing atmospheres, the Oort cloud remains a sanctuary of stillness, a place where the history of the universe is kept under a lock of cold and gravity. Consider the star Gliese 710, which scientists discovered is heading toward us at a speed of 14 kilometers per second. In about 1.3 million years, it will pass through the Oort cloud, coming as close as 10,000 astronomical units to the Sun. This event will be a grand, silent meeting of two star systems, a gravitational handshake in the dark. But for now, that star is nearly 60 light-years away, a distant blue spark that poses no threat to the quiet. You are existing in a window of perfect peace, a long era of stability where the Oort cloud serves as a soft, dark blanket for the entire solar system. Notice how the weightlessness feels in your limbs. Without the 9.8 meters per second squared of Earth's gravity, there is no strain on your joints, no pressure on your back. You are a point of consciousness in a realm of 10 to the power of minus 12 atmospheres of pressure. Allow this lack of physical tension to mirror the lack of mental tension. In the Oort cloud, there are no deadlines, no requirements, and no noise. There is only the slow, rhythmic dance of ice, the 2.7 Kelvin cold, and the infinite, comforting dark. In the final part of our journey, we will begin our slow descent back toward the warmth of the inner worlds, carrying the silence of the Oort cloud with us into sleep. But for now, stay here in the velvet warehouse. Smell the ancient chemistry of the ammonia and methanol. Touch the fragile, snowy surface of the ancient ice. Notice the steady, unblinking light of the distant sun. You are part of the Oort cloud's archive. You are a frozen memory of the stars, resting in the heart of the void. Everything is stable. Everything is quiet. Everything is as it should be. As our journey through the outer reaches of the sun's influence begins to slow, imagine your awareness gently descending from the heights of the outer Oort cloud, that magnificent spherical shell that scientists discovered extends as far as 200,000 astronomical units into the void. At this immense distance, nearly halfway to the next star system, the gravity of our sun is so tenuous that a single icy traveler might take 30 million years to complete one loop around its parent star. Picture this. The object we are observing now began its current orbit when the Earth's climate was significantly warmer, and the very first ancestors of modern horses were just appearing on the plains. The Oort cloud operates on these vast geological timescales, and as we observe the process of a comet's life, we find a rhythm that invites the mind to release its attachment to the fleeting hours of a single day. Notice how a change begins with a subtle gravitational nudge. This process is often initiated by the galactic tide, a gentle stretching of the Oort cloud caused by the collective mass of the Milky Way's disk. Scientists discovered that our solar system completes one galactic year, a single revolution around the center of the galaxy, every 225 to 250 million years. As we move through this grand circle, the varying density of nearby stars and gas clouds provides a rhythmic, repeating pull. At this very moment, imagine a passing star, similar to the red dwarf Schultz's star, which brushed past our system 70,000 years ago, providing just enough of a gravitational ripple to break the equilibrium of an icy mountain. What's happening now is a step-by-step transformation. The object once held in a stable circular orbit at 50,000 astronomical units begins to fall toward the inner solar system. This is not a rapid plunge, it is a slow, graceful migration. Because the orbital velocity in the outer cloud is a mere 0.2 kilometers per second, the initial acceleration is almost imperceptible. For hundreds of thousands of years, the comet simply moves from the outer shell into the inner Oort cloud, also known as the Hills cloud, which scientists discovered begins at roughly 2,000 astronomical units. This inner region is shaped like a thick donut, acting as a massive reservoir that holds billions of potential travelers. As the comet continues its inward journey, observe the process of environmental change. For eons, the object has been kept at a temperature of 3 Kelvin, just 3 degrees above absolute zero. At this temperature, ices of nitrogen and carbon monoxide are as solid as the foundation of a building. However, as the object crosses the boundary of the heliopause, the region about 120 astronomical units from the Sun, where the solar wind meets the interstellar medium, the environment begins to shift. Scientists discovered that the Voyager 1 spacecraft crossed this threshold in 2012, and although it is moving at 17 kilometers per second, it will still take another 30,000 years to fully exit the Oort cloud's outer reaches. The scale of this transition is a testament to the immense volume of the solar system's backyard. Consider the thermal process that occurs as the comet reaches the frost line, located roughly 5 astronomical units from the Sun, in near the orbit of Jupiter. Until this point, the comet has been a dark, silent stone. But now, the Sun's energy becomes strong enough to trigger sublimation. This is the process where ice turns directly into gas without becoming a liquid. Scientists discovered that different ices sublimate at specific temperatures, while water ice begins to vaporize at about 150 to 180 Kelvin in a vacuum. Carbon monoxide ice can begin to outgas much further out, creating the first faint hints of a cometary tail. Picture this. The dirty snowball is now waking up. The gases trapped within the amorphous ice, the disordered molecular structure we explored earlier, begin to expand and burst through the dark reddish crust of tholins. This creates jets of vapor that carry dust particles away from the nucleus. Scientists discovered that these dust particles are often microscopic silicates, the same minerals that make up the Earth's mantle. In 1997, comet Hale-Bopp displayed this process beautifully, releasing nearly 2,000 tons of dust every second at its peak. As you observe this transformation, Realize that you are watching the release of materials that have been kept in a perfect state of preservation for 4.6 billion years. The journey inward eventually reaches its perihelion, the point in the orbit closest to the Sun. For some comets, this might be millions of miles away, while sun grazers can pass within 100,000 miles of the solar surface. Scientists discovered that the intense heat at perihelion can cause a comet to fragment, as happened with Comet West in 1976. But then, the process reverses. The comet, having shared its ancient chemistry with the inner solar system, begins to climb back out into the dark. It slows down, the outgassing stops, the tail disappears, and it returns to the silent, frozen state of the Oort cloud to spend another several thousand years in the quiet. Now, bring your focus back to your own physical presence, much like a traveler returning to a warm home after a journey into the cold. You are intimately connected to this cosmic process. Scientists discovered that the deuterium to hydrogen ratio in some Oort cloud comets matches the ratio found in Earth's oceans, suggesting that the very water that supports your life today may have arrived via these icy messengers. The carbon in your muscles and the nitrogen in your DNA were once part of the same primordial nebula that formed the Oort cloud. You are not a stranger to the void. You are a part of its complex, beautiful architecture. Notice how the vastness of the Oort cloud begins to feel like a protective layer around you. Just as the cloud's estimated 5 Earth masses of material form a protective halo around our star, your own mind is creating a halo of peace and stillness. The 3 Kelvin cold of the Oort cloud is now the cool, refreshing air in your room. The absolute silence of the vacuum is now the quiet of your home. The weightlessness of 50,000 astronomical units is now the lightness of your limbs as they sink into the mattress. The observation of the cosmos is coming to a gentle halt. The trillions of icy bodies continue their slow, rhythmic circles, unhurried and undisturbed. They are the solar system's silent memory, and you have accessed that memory tonight. And the clockwork of the universe is stable. The gravity of the sun is unyielding. The stars are steady. Allow yourself to transition from the macroscopic beauty of the universe to the internal warmth of your own rest. The same physics that govern the orbit of the 137-kilometer-wide comet Bernardinelli-Bernstein govern the rhythmic rise and fall of your chest. You are synchronized with the galactic tide. You are a star child returning to the source. As you drift into the silence of the void, carry these affirmations for rest with you. I am made of stardust, and I am returning to the peace of the stars. My body is as stable and secure as a celestial orbit. I release the heat and energy of the day, embracing the cool stillness of the dark. I am unburdened by time, existing in the vast, patient scale of the cosmos. Every breath I take is a reflection of the rhythmic pulse of the galaxy. I am safe in the comforting void, surrounded by the protective history of the universe. The silence around me is a sanctuary for my mind to rest. I am a traveler who has found the way back to total tranquility. The darkness is not an end, but a soft velvet curtain for my dreams. I am part of the Oort cloud's grand silent dance. The sun is now a distant soft spark. The planets are far away, moving in their predictable paths. You are here, in the heart of the quiet, at the very edge of the solar system, where nothing is required of you but to exist. The ice is still. The vacuum is pure. The dark is warm and inviting. Sleep now, knowing that the archive of the universe is safe. The trillions of icy messengers will be there when you wake, continuing their million-year journey through the deep. But for now, the journey is over. You have reached the destination of perfect rest. The void is holding you. The stars are watching over you. The silence is your song. Good night.